Hello everyone, welcome to the second part of the video. In this video, we are going to solve rest of the problems from part A, NEET 2023. So our first problem is, light travels a distance x in time t1 in air and 10x in time t2 in another denser medium. What is the critical angle for this medium? And these are the four options. So according to the question, there are two mediums of refractive index n1 and n2, and let's consider n1 is greater than n2. Now a ray refracted from the first medium to second medium with incidence angle θ1 and θ2. Now we know from the formula of critical angle that sin θc is equals to n2 by n1. Here n2 is the rarer medium and n1 is the denser medium. Again, sin θc can be written as the ratio of two velocities v1 and v2. Here v1 is the velocity in medium with refractive index n1 and v2 is the velocity in the medium with refractive index n2. Now we know velocity is defined as distance over time. Therefore, we can say that v1 is equals to 10x by t2 and v2 is x by t1. Now if we put these two relations in the above expression, that is in sin θc equals to v1 by v2, then we can write sin θc equals to 10x by t2 times t1 by x, which gives θc is equals to sin inverse 10 t1 by t2. Therefore our correct answer is option C. Now let's go to our next problem. Our next problem is, a 12 volt 60 watt lamp is connected to the secondary of a step down transformer whose primary is connected to AC mains of 220 volt. Assuming the transformer to be ideal, what is the current in the primary winding? And these are the four options. Now for ideal transformers, we know that Vp times Ip is equals to Vs times Is, that is power in primary coil is equals to the power in secondary coil. Now according to the question, it is given that Ps equals to Vs times Is, which is equals to 60 watt, and Vp is, that is the voltage drop across the primary coil, is equals to 220 volts. Therefore Ip can be calculated from this formula. So now if you put the value of Ps and Vp, then you will get Ip is equals to 0.27 ampere. Therefore option D is the correct answer. Our next problem is, a football player is moving southward and suddenly turns eastward with the same speed to avoid an opponent. The force that acts on the player while turning is, and these are the four options. That is, we need to find the direction of the force acting on the player. So to solve this, let's draw the diagrams. So at first the football player is moving southward, then suddenly it turns eastward. Now extend this blue line. So basically this blue arrow and red arrow indicates two vectors. You can say that this red arrow is the resultant vector and the dotted or dashed blue arrow is one vector, and we need to identify another vector such that their resultant is the red vector. Now from the figure, as you can see, the dashed arrow and the red arrow are both perpendicular to each other. So the other vector must act along this orange arrow. So you can say that this red arrow is the resultant of this blue arrow and the orange arrow. So the correct answer is option B, that is the force acts on the player in the northeast direction. Our next question is, the magnitude and direction of the current in the following circuit is, and these are the four options, and this is the circuit diagram. So from the circuit diagram, we can say that the magnitude of the current is I is equals to E effective by total resistance, which is equals to 10 minus 5 as the cells are in opposite polarity, and R total is the sum of the resistances, which is 10. Therefore, I is equals to 0.5 ampere. Now, the current should flow from point A to point B through point E. That is, option A is the correct answer. Our next problem is the angular acceleration of a body moving along the circumference of a circle is along the radius towards the center, along the tangent to its position, along the axis of rotation, along the radius away from center. Now, to solve this problem, let's draw a diagram. Let's consider this as a circular path and the particle is moving along the circumference of the circle. So, at any instance, this is the linear acceleration acting on the particle and it's directed along this blue arrow, and the position vector is directed along this red arrow. Now, angular acceleration is defined as alpha equals to r cross a. So, the direction of angular acceleration should be perpendicular to the plane containing both r and a, that is both radius vector and linear acceleration. Therefore, option C should be the correct answer, that is the angular acceleration of a body moving along circumference of a circle acts along the axis of rotation. Our next problem, a bullet is fired from a gun at the speed of 280 meter per second in the direction of 30 degree above the horizontal. The maximum height attained by the bullet is, and it is given that g is equals to 9.8 meter per second square and sine 30 degree is equals to 0.5, and these are the four options. So, it is given that speed of the bullet, which you can say the initial speed is 280 meter per second and theta is 30 degree. Now, the formula for the maximum height of a projectile is h is equals to u square sine square theta by 2g. So, if you put all the values, then 280 square times sine square 30 by 2 times 9.8. So, you have to calculate this. This is equals to 1000 meter. Therefore, option B is the correct answer. Now, let's solve our next problem. The net magnetic flux through any closed surface is, four options are given: positive, infinity, negative and 0. Now, we know that according to Gauss's law of magnetism, the magnetic flux through any closed surface is proportional to the total magnetic charge enclosed within that surface. However, unlike electric charges, magnetic charges, also known as magnetic monopoles, do not exist in nature, and so the total magnetic charge enclosed within any closed surface is always 0. Therefore, according to Gauss's law of magnetism, the magnetic flux through any closed surface must be 0. This means that any magnetic field lines that enters the surface must also exit the surface, either through the same or different region of the surface. Therefore, the correct answer is option D. The equivalent capacitance of the system shown in the following circuit is. Now, to solve this problem, we need to identify which capacitors are in parallel combination and in series combination. So, as you can see, these two capacitors are in parallel combination. So, their equivalent capacitance should be add up, that is their equivalence capacitance is 3 plus 3, which is 6 microfarad, and this equivalent capacitance is in series with the third capacitor. So, you can say that the total equivalent capacitor of this circuit, which you can denote with CEQ, is equals to 1/3 plus 1 over 3 plus 3. So, CEQ is 2 microfarad. Therefore, option D is the correct answer. Our next problem, a vehicle travels half the distance with speed v and the remaining distance with speed 2v. Its average speed is, and these are the four options. So, let the total distance is x. Therefore, the vehicle travels the distance x by 2 with speed v and another x by 2 with speed 2v. Therefore, total time taken is capital T is equals to x over 2v plus x over 4v, which is equals to 3x over 4v. Now, from this we can calculate the average velocity, which is v average is equals to total distance by total time. Now, total distance is x and total time required is 3x by 4v. So, if you put this, then you will have V average is equals to 4V over 3. Therefore, option B is the correct answer. The half-life of a radioactive substance is 20 minutes. In how much time the activity of substance dropped to 1/16 of its initial value? So these are the four options. So it is given that T half is 20 minutes and we have to find the time at which n is equals to 1/16 times n naught, that is it's 1/16 times of its initial value. Now since the half-life of the substance is 20 minutes, this means that after every 20 minutes the number of radioactive nuclei present in the substance will be reduced to half of its previous value. Therefore, we can say that n over n naught is equals to 1/16, which is equals to half to the power t by t half. So here t half is 20, therefore it is half to the power t by 20. Now this 1/16 can be written as 1/2 to the power 4. Therefore we can say that t is equals to 80 minutes. So it takes 80 minutes for the activity of the substance to drop to 1/16 of its initial value. Therefore option C is the correct answer. Our next problem is the temperature of a gas is minus 50 degrees Celsius. To what temperature the gas should be heated so that the RMS speed is increased by 3 times? And these are the four options. So according to the question, it is given that the temperature of the gas is T1 equals to minus 50 degrees Celsius, or if we convert it into Kelvin, then it is equals to 223 Kelvin. Again, we know that the RMS speed is directly proportional to the square root of the temperature, that is Vrms is proportional to square root of T. Now we need to find the temperature at which the RMS speed will increase to 3 times its initial value. So Vrms prime is equals to 3 times Vrms. Now from the above relation we can write it as Vrms prime by Vrms equals to 3, which is equals to square root of T prime by T. So T prime is equals to 3 square T or 90. Therefore T prime will be 1734 degrees Celsius. But this doesn't match with any options given. So none of the options are correct. But if you consider that the velocity would rise to 4 times its initial velocity, then by using the same formula, you can get T prime is equals to 3568 Kelvin or 3295 degrees Celsius, which matches with the option A. So I think this question is not a valid question. And according to the statement of the question, the correct answer should be 1734 degrees Celsius. Now our next problem is, a Carnot engine has an efficiency of 50% when its source is at temperature 327 degrees Celsius. The temperature of the sink is, and these are the four options. So it is given that efficiency of the Carnot engine is 50% and the source temperature, which is T2, is equals to 600 Kelvin. Now we know that efficiency is given by eta equals to 1 minus T1 by T2. Therefore T1 can be expressed as T2 times 1 minus eta. So if you put the value of eta and T2, then you will get T1 is equals to 300 Kelvin, or it is equals to 27 degrees Celsius. Therefore option D is the correct answer. Now let's solve our next problem. The magnetic energy stored in an inductor of inductance 4 microhenry carrying a current of 2 ampere is, and these are the four options. So it is given that L is equals to 4 microhenry and the current I is equals to 2 ampere. Therefore magnetic energy stored will be U is equals to half Li square. So if you put the value of L and I in the same unit, that is in the SI unit, then you will get the total magnetic energy is equals to 8 microjoule. Therefore option C is the correct answer. we know that the longitudinal stress is given by the ratio of force over area, and here it is given that the force is equals to tension in the wire, which is equals to capital W, that is the weight. Therefore, the option A is the correct answer. Our next problem is, an electric dipole is placed at an angle 30 degree with an electric field of intensity 2 times 10 to the power 5 Newton per Coulomb. It experiences a torque equal to 4 Newton meter. Calculate the magnitude of charge on the dipole if the dipole length is 2 cm. And these are the 4 options. So it is given that theta is equals to 30 degree. The magnitude of the electric field intensity is 2 times 10 to the power 5 Newton per Coulomb, and the value of torque is 4 Newton meter, and the length of the dipole is 2 cm. Again, we know that torque acting on an electric dipole is given by the formula tau is equals to P cross E, where P is the dipole moment and E is the electric field. Or this can be written as mod of tau is equals to mod of P times mod of E sin theta. Now this mod of P is the dipole moment, which can be expressed in terms of charge and the distance between the charges. So this is P is equals to Q times D, or Q can be written as D times E sin theta over tau. Now if you put all the values of D, E, theta and tau, then you will get the value of Q, which is 2 millicoulomb. Therefore, the correct answer is option C. Our next problem is, in hydrogen spectrum, the shortest wavelength in the Balmer series is lambda. The shortest wavelength in the bracket series is, and these are the 4 options. So, in the hydrogen spectrum, the Balmer series corresponds to transition between higher energy levels and the second energy level, that is N is equals to 2 of the hydrogen atom. And the bracket series, on the other hand, corresponds to transition between higher energy levels and the fourth energy level. Therefore, the shortest wavelength in the Balmer series is given by 1 over lambda is equals to RH times 1 over n square minus 1 over infinity square. Here infinity represents the highest energy level. Now if you put n equals to 2 for Balmer series, then it can be written as 1 over lambda is equals to RH over 4, or lambda is equals to 4 over RH. Here RH is Rydberg constant. Now let lambda be the shortest wavelength in the bracket series. Therefore lambda b is equals to 16 over RH, as n is equals to 4. Therefore the ratio lambda b over lambda is equals to RH over 4 times 16 over RH, which is equals to 4. Therefore you can say that lambda b is equals to 4 times lambda. Therefore the correct answer is option A, 4 lambda. Our next problem is, the ratio of frequencies of fundamental harmonic produced by an open pipe to that of closed pipe having the same length is 2:1, 1:3, 3:1 and 1:2. So we know that the fundamental frequency of a pipe depends on its length and the boundary condition imposed at its end. The fundamental frequency of an open pipe is given by F naught equals to V over 2L. Here V is the speed of sound in air and L is the length of the pipe. Again, the fundamental frequency for a closed pipe is given by Fc is equals to V over 4L. Therefore, the ratio will be F naught over Fc is equals to V over 2L by V over 4L, which is equals to 2. Therefore, option A is the correct answer. Our next problem is, two bodies of mass m and 9m are placed at a distance r. The gravitational potential on the line joining the bodies where the gravitational field equals to 0 will be, and these are the 4 options. Now to solve this problem, let x be the distance from the mass m at which the gravitational field is 0. Therefore under this condition we can write gm over x square is equals to g times 9m over r minus x square, which is equals to r minus x equals to 3x, or from this we can determine the value of x, which is equals to r over 4. Therefore we can say that at a distance r over 4 from the mass m, the gravitational field is 0. Therefore the gravitational potential will be u is equals to minus gm over r by 4 minus 9 gm over r minus r by 4. Now if you calculate this, then you will get u is equals to minus 16 gm over r. Therefore option B is the correct answer. So that's it for now. In the next video we will solve the part B of NEET 2023.